for today, we're going to do the exercise number 5, Introduction to Numerical Analysis. So first is to go to the command and run, look for it. Then it will load all the libraries that we are going to use in our experiment. So next one is to do the input-output of data from command window. So this is the command window. We're going to input this tree, which I've already made here pre-video for the debugging. And then we will have our results of matrix A, B, and C. And then we will save this as ABC. So save ABC, ABC to a math format. So that it will have abc.mat file. So we can see it over here. We'll have this ABC math file. Oh no, this error is due to not running Matlab in administrator. Wait, let me fix it. Matlab run as administrator. Yes. So again, let's for repeat, and then you will enter these values for the input output of data from the command window. So, and then for the save ABC, ABC, see, we fixed that error. And then I found out that we can also use this save function var and then save a. Right, so, oops. So we can do save variation of a variable a or save variable b. So this was like this one. So yeah, we don't need that because we already have this one. So let's just do the next is to clear AC, but then we need to get the value of A. So to show the value of A, we just enter A and then let's see the value of A from here. Then to clear AC, then the variables of and values of AC over here has been cleared. Then to load the values of AC that we have deleted from the AB from the saved ABC format, we'll use load ABC AC. That's pretty direct, so we can see it's back here. Then next is to save, or we can also load again the A value, and then save B dot B. So we're using Matlab, so instead of slash, we're going to use dash as to store the data in IC.5. And then hit enter, and then you will have this B.5 over here in C format. And then load B dot read the value of variable from preceded. So yeah, this is the B type. You can see the values from the variable b in beta. So this is the beta format. And then next is to letter B input output of data using keyword. So I've already prepared that code. So yeah. For this code, x is equals to input tapos variable of enter x value, and then format rat x, format long x, long. So basically these are the as a rational number, as a decimal number with 14 digits, as a long exponential form, and as hex, as a short exponential. Let me write. Yeah, I'm right. So then back to default. So display value of x is equals to display. So here we are asked to enter x or the value of x. So let's say my sig number 41. Then we will get the x value in rational form, and then in 14 decimal, and 14 decimal number with 14 digits, and then back to the value of x is 41. So yeah. The next thing to do is um, here do the following program before below. So here do the following program below. So this is for Fahrenheit. I've already made code here. So for this one, we will get the input temperature Fahrenheit and then its equivalent value in its centigrade. Let's say input temperature Fahrenheit is around 200. So Fahrenheit in 200 centigrade or the Celsius is around 93.33. So 200 in Fahrenheit is 93.33 in centigrade. And then after that, uh, we should have been asked if the answer is yes or no. Hmm. Oh, I forgot. Let's just check. Answer is equals to input answer yes or no. So in the program, we will be asked if the answer no, then comma. Yeah. So 200 in Fahrenheit is 933 in centigrade. So let's see if it's yes or no. 200 Fahrenheit to 93.33 in centigrade. So the answer is yes. So in Celsius, it is 93.33 degrees Celsius. So the answer is yes. So my seat number is 41, which lands into Heron's formula. So it's about the triangle. I already made a code about it. So here, this is a calculator. Oh, ito pala yung ano ko. So for the calculator of Heron's formula, my seat number is 41. The lengths, this is for the code to input the sides. So we have three sides, which I named ABC. So for the calculating the semi-parameter, we have the formula S is equal to side of A plus side of B plus side of C divided by 2 to get the semi-parameter. So for calculating the area using Heron's formula, the formula is area is equals to square root of side times times s- side minus side of A times side minus side of B multiplied by side minus side of C. So yan. Then we will have the call out command of input result. So f print f. The area of the triangle is uh let's see. The area of the triangle is 0.2f of n. So the last one is to print the result. So hit enter. So we would be asked about to enter the length of side A. So let's say for the side A we will have 45. Side B will have 45 as well. And then for the side C is around 65. The area of the triangle is 1011.55. So we have given the answer. Then next is graphic input. So then dito. Yeah, 2D graphic input. So next one is 2D graphic input and output. Store the data reflecting the highest and lowest temperatures for 5 days are stored as a 5 times 2 array in an I. So the next one is the number 3, 2D graphic input and output. So we are tasked to store the data reflecting the highest and lowest temperatures for 5 days, stored as a 5 by 2 array in an ASCII file named temp. That. So here we're going to input this as a code function, which I've already made earlier upon debugging. So here for the array, so dito lang muna tayo. So here, let's input for the, this is the array. Then we need to save this into a file named temp.data. Then we are going to load the temp.dat over here and then uh, plotting the temperature and then having the title. These are the title. Highest and lowest temperature of let's say for this. For this. So yan. Then for the Y label is the degrees and then the X label is the day. So if we are going to do that. So this is the Y label or Y axis degrees in Celsius and then this is the days in X label. So yeah. So this is our array for 5 days. So this is 32, where's that? 32, 35, and then 33, 37, up to 36. So yeah, next is to, where are we? This one. So now do the following codes and explain. So for this one, for the days is equals to, yan, let's get down. Now let's do the these days for figure one, and then figure two, figure three, and figure four. So first, let's do the figure one. So for figure one, we'll have this. So here we can see figure one and figure two. Oh, I accidentally hit the figure two. Anyways, let's minimize it. So for figure one, plot days and time axis 10, 20, 0, 30. So 10, 20 hanggang 10. 0 to 30, 10 hanggang 20. So the grid is on, which is this one. And then mm, it says explain. So for this one, it changes the days from the old array to the X label and Y label. And then that's a 9. The second figure, lagay na natin lahat here. Hanggang figure. So for figure 3, so here, um, so in figure 3, it will create an equal axis from X and Y, which will result to a square equal intervals. Then for the figure 3, figure 4, so for the figure 4, the plot in blue line is the plots in blue line are the days, and then the dot over here are the temperature. So temperature 1 and temperature 2. Then next is to mm, after that, I'm going to do drawing. So for the next one is to draw a circle. So here. Next one is to draw a circle, which this one makes a lot of cosine, which we can see in table over here. And then so this plot will make a circle color um semilog in x-axis, semilog in y-axis, and then exponent of th, stairs, stem, bar h, histograph, and histograph of these values. So let's check. So here are the values. Then you can see over here the plots. So for the plots, hmm, wait, let's plot the polar first. Polar. This is the polar. So from the polar, we have column 1 through 6. and then so here we have um so let's go polar. So this is the polar graph. Then we'll do this one, the pi, same polar, semi, semi-log, and log. So here, it's logging. Then this is the polar, and then semi-log through x, and then semi-log through y, and then log. Exponential, exponential, exponential th. Um, yeah, negative. So next is to do the stair stem bar, and that is the graph. So this one here, these are the bar and the histogram. So yeah, stem and then bar and histogram. So then let's go to um, the 3D graphic output. So for this, so for this experiment number, like for this experiment, we're going to use plot, mesh, contour, plot tree, and yeah, for doing our 3D plots. So let's input these. We're dividing two screens, two sections. So you can see, we can navigate through that for our grid. So we have mesh, it's a mesh from the um dividing screens into two sections. And next is that's the elevation, that is at negative 37 degrees. Then it's the contour right here, and then next one is to last one is the mathematical function. So for this one, we will use the variables and functions. So we're going to store in Octave these functions. Oh no, these functions for a scalar valued function. So in our Octave, I've already made that. So for this one, for the function of yf on x, this function, I'm going to save that hit run or control S, but I've already saved it. So we're going to have a file named f1 in .m format. So for the f49, this function is the f49. We have a separate file for these to call them out later on. So for our next is um, is to call out these files. We will now input the f1 of value 0, 1 for the scalar function, scalar variable. So this. So I typed it out for the call out using the stored functions. I'm going to run this. So these are the results. So for y, we have this. And which results are also the same with using fval of f1 and values of a variable of function f1. And then same with using f49 and then variable of 0, 1. So next, so it is equivalently yields the same. So yeah, same value, same results using pval and just calling out the f49 f1 of the values. So for the final task, we will do the polynomial function, which p of x is equals to x cubed minus 3x plus 2. So we're going to input this polynomial value. So here is the code. So yeah, the answer is 2, 0. the answer is 2, 0. So yeah, that's all for our today's experiment. And in my conclusion, overall, I've learned to call out and calculate, save data with using file and using keyboard and command window. And then we can also calculate for the input and output of these values, as well as the calculating the Fahrenheit into getting the Celsius using our Matlab or Octave. Then making an interactive code, which you will be asked if the answer from these are true, which is yes or false if it is no. And then from my seat number Heron's formula, we will get the calculation of a triangle, getting the area using Heron's formula, which will have a simple formula of getting and inputting the three sides of a triangle, which are called out as A, B, C. And then the command will ask you about the values of the A, B, C, and then after that, it will give you um, the perimeter area result of the given sides. So, and then for the 2D graphic, which are the lines, more on the lines, we'll have the arrays, and then we have been given the anong tawag dito? Or the we can see the so for the 2D graphic, we will see the arrays in such a way that 2D with the lines in that are in straight, horizontal, and polar, semilogs, um, log, and histographical, as well as having a 3D, which can give us more of nice visuals into it by giving us the contour and mesh, which was divided by 2 by 2. And then, yeah, and then with our functions, by inputting our function, by inputting our given functions, we can call out these files that we have already saved in our directory. Uh, by running this program, we can either use eval or just use the function and call out the variable. And that's all. Thank you.